Today we are going to find the integral of tan cube of x, and we are going to integrate it with respect to x. So we have an odd power of tan here, and we need to integrate it. We will break it into tan square of x into tan of x, and whenever we have tan square of x, we just use the identity 1 plus tan square of x is equal to secant square of x. And why do we do that? Because we know the integral of secant square of x, and that is tan of x, because the derivative of tan of x is secant square of x. So we from this identity we can find the value of tan square of x, which is secant square of x minus 1. We'll just put that value of tan square of x here. So this will become the integral of secant square of x minus 1 into tan of x dx. Tan of x is being multiplied with secant square of x minus 1. We'll just distribute it. It will become tan of x into secant square of x minus tan of x. And this, we are integrating this whole expression with respect to x. So we can see that in the first term we have tan of x into secant square of x. We can easily integrate this term because uh, we have a function tan of x, and its derivative is written right next to it, which is secant square of x. So whenever we have this kind of situation, the answer is just that function raised to power its power plus 1 divided by the same power. So what I am saying is that whenever we have a function and its derivative written right next to it, the integral is that function raised to power its original power, which was 1 plus 1. So the whole expression becomes x square divided by 2, the same power which was here, plus the constant of integration. Here the function is x and its derivative is 1. But here we can see that the function is tan of x and its derivative is secant square of x. And the result will be same, function raised to power its original power, which was 1 plus 1. So 1 plus 1 becomes 2. So this becomes tan square of x divided by 2 minus, we have this integral of tan of x. And we know how to integrate tan of x. Tan of x can be written as sin x over cos x, and we will move this negative sign inside the integral because we so I was saying that we can find the integral of tan of x uh, simply by writing tan of x as sin x over cos x, and we are moving this negative sign inside the integral because we know that the derivative of cos of x is minus sin of x. And whenever we have this situation, like we have a function and the derivative of that function is written right above the function, the derivative is natural log of absolute of that function divided uh, sorry plus the constant of integration. So we have cos of x and its derivative is written right above it. So the integral of this will be natural log of absolute of that function, which is cos of x plus c. So this is the derivative of, sorry, integral of tan cube of x.